Hey guys, what is up? It's your pal Dave from notesandvolts.com and welcome to part 8 of the Teensy-Synth tutorial. Today we're going to program an LFO or low frequency oscillator that will allow us to control the pitch and filters on the synth and let us do something like this. Let's take a look at how this new LFO section works. So you can see on the control panel I've added the LFO section. It's got a speed control, a depth control, control to control the modes, and a button to select whether you're going to affect the filter or the pitch. So if we start on the filter section, if I set the control to free, it's just going to allow the LFO to sweep up and down and control the frequency of the filter. This speed control will select how fast it's going to go. So let's take a listen. Now there's a couple of other modes, so we can select down, up, one down, and one up. Now if you change the mode to down, what's going to happen, it's going to re-trigger the LFO every time you hit a key. So it's always going to start at a high level and then sweep down to a low. Now if we change it to up, it's going to do the opposite. It will start the filter at a low frequency and raise it up. Now in both these modes, once the filter has gone through a sweep, it's just going to continue freely. So take a listen to that. And it will just keep going like that. Now the one down and one up basically work the same way as down and up, but it's only going to sweep once, and once it reaches the bottom, it's going to stop. And the same with up. Right? So once it reaches the top, it's going to stop. Now in filter mode, you can set the lower frequency of the filter with the depth control. So as I move this up, you'll hear the bottom frequency kind of raise up. So let's take a listen. And the filter control is going to set the upper limit of the LFO. Alright, so all you have to really remember is that the depth control in filter mode sets the bottom of the filter, and the frequency control sets the top of the filter, and the LFO is going to sweep between those 2 points. Now if at any point you raise the depth control above the frequency of the filter control, it's just going to act like the filter. I also added a second LFO type that will control the pitch, and the modes work the exact same as on the filter, but the depth control is actually going to change how high the note's going to swing. So let's set it to free and we'll listen to how that sounds. And we'll slow it down. And the one down and one up, as always, will just sweep it once and then stop. Alright, so that's a neat effect. So if you don't care about any of the technical details of this, you can just load this into your Teensy-Synth like we've done in the past and just enjoy. But for the rest of you, let's take a look at the code behind this and get into the technical details. Okay, so first of all, let's take a look at the actual pure data control panel and see what I did there. So if we open up that panel, you can see that the speed control is on MIDI CC number 114, the depth control is on 115, and the type and mode buttons are outputted on CC 116. Now they kind of work an interesting way. So let's select the filter first and take a look at this box. So this is showing what is actually being output on MIDI CC 116. And if I select off, you see we get a 0, and then I get 1, 2, 3, 4, 5. Now, when I switch to the pitch mode, if you notice, both these controls are connected to the same CC number. And the reason I did that is I want to conserve the amount of MIDI CC channels I'm using. So we're going to get both of these onto the same channel. And the way I did it is by taking the output of this type control, which can be 0 if it's filter or 1 if it's pitch, and I'm multiplying that by 8. And then once I get that total, I'm going to add it to the result of the mode control. So if we go back to 0, if I select pitch, it's going to set the pitch control at 1, multiply it by 8, so you notice I'm getting an 8 out. And now as I increase the controls, I'm getting 9, 10, 11, 12, 13. So that's basically how this works and how we can get both controls on one CC channel. As always, click the link in the video description to download this control panel and the software as well. Okay, so now let's take a look at the code. So once you've downloaded this software, this is Teensy-Synth Part 8 LFO test. The LFO is controlled by this function here, LFO update. And basically this variable, which is a float, holds the value of the LFO, and it can be 0 to 1. So it's actually a percentage. And the reason why I used a percentage is that I can now assign it to any parameter I want. So I could assign it to a control from 0 to 127 or a frequency to 20,000 hertz. Doesn't matter. It's always going to be a percentage of that total. So this LFO variable is going to increase and decrease in a wave from 0 to 1 and then back down to 0. Now to control the timing of the LFO, I'm using the micro clock, which is the microsecond clock in Arduino. And basically, if you're not familiar with this, as soon as you power up Arduino or the Teensy board, a clock starts and it counts from 0 and it starts counting how many microseconds this thing has been on. And you can use that to keep track of intervals of time. So first of all, let's take a look at how our function's being called. So in our main loop, which is right here, you notice I've added a new function, this LFO update call. And if you're not familiar, the main loop basically is called continuously throughout the program. So all it's really doing is it's checking if there's MIDI signals available, and it's also checking if it's time to update the LFO. Now let's skip down to our MIDI CC control, which I've set to 114 for the speed of the LFO. So basically this is setting the number of microseconds between each tick of the LFO, or each time the LFO updates. Once we've got the number of microseconds between each tick of the LFO clock, we're going to go and check out our LFO update function, and every time this is called, there are two variables that it's going to check. So LFO time is basically originally set to 0 because it's starting at 0. And current micros is going to take a sample of the microsecond clock and see what the time is. And if you look here, this if statement, if the current time minus the last time it was checked is greater than the LFO speed, or if the amount of microseconds our speed control is set, that will mean enough time has passed that we should do something. If it's not time yet, this is just going to do nothing and exit the function. So we're checking if the amount of time set by our speed control has passed. And if so, we're going to update the LFO. And the LFO is updated in this section here. And it's actually very simple. I'm updating it in kind of a sawtooth fashion. So all I'm doing is if it's headed in one direction, I'm just increasing it by 0.01 each time the LFO ticks. And if it reaches 1, I'm going to switch directions, and this will be called, and it's going to go down by 1. So it's basically increasing by 0.01 until it gets to 1, and then it's going to switch direction and decrease by 0.01 until it gets to 0. And it's going to keep doing that over and over again at the speed set by our speed control. Now, one thing to notice in the MIDI CC section, and if you've been following this tutorial, you're very familiar with this. This is our little function that turns our input from our speed control into a percentage from 0 to 1. And we've used this many times, so hopefully you're familiar with it from the past episodes. What we're doing with it may seem a little complicated, but it's actually pretty straightforward when you look at it. So let's take a look at that. Okay, so like we said, this speed control is basically putting out a percentage, so it's going from 0 to 1. And you can think of it kind of sweeping along this x-axis here. Now, normally what we've done is we've just done something like this. So basically, our y-axis has always been a linear relation to our x-axis. So as we turn the control up and our x-axis increases, the y-axis is going to increase at the exact same amount. Now, what you'll find if you set it up like this, it will work, but it's not going to feel very good. So what I wanted is when the control was low and the frequency was the highest, I wanted more control or finer control over those frequencies so you could dial in those quick frequencies very precisely. And as the frequency gets higher, I want it to move quicker. So the way we have to do that is by using an exponential function, and that's what I've done here. So here's the actual function I'm using. So the amount the control is affecting the time is controlled by this function. All right, and now you can see we have this kind of curve, and this is an exponential curve. And you can see as I move the control along the lower range, I'm actually only increasing very slowly. So it's increasing the frequency very slowly, and as I get up into those higher, longer frequency, it's going to increase it a lot quicker. So I've got all this control in this low range and then a big sweep up to the longest range available. So that's really all this code is doing, and it's a good way to turn a linear potentiometer into more of a logarithmic potentiometer. So hopefully that makes sense. It's a little bit of math, but what can you do? Math. So once I've got my microsecond frequency for each clock tick of the LFO, I'm going to call it and I'm going to send it some parameters. So first of all, I'm going to send it a retrigger parameter, a mode select parameter, which is going to determine which mode is selected on your control panel, the current state of the filter, and the current state of the LFO depth control. And here they are coming in to the function. Now the retrig control is going to come into effect on these modes where I need to retrigger or restart the LFO every time the key is pressed. So when the key is pressed, and remember, every time I press a key, the myNoteOn function is called. And here I'm updating the LFO. So every time I press a key, I'm going to update the LFO and set the retrigger flag to true. Notice when I'm calling the LFO update in the main loop, I'm setting the retrigger flag to false. Now the LFO mode select is, as we said, is selected by MIDI CC 116, and all that's doing is basically taking the value that comes in and setting it to a variable LFO mode select. So when I call the function, I'm going to send the correct mode in this variable here. The filter factor is the current state of the filter, which is going to determine how high the frequency of the filter is, and the LFO depth variable is going to be set by MIDI CC 115, and that's a simple percentage 0 to 1. Okay, so now we're ready to go. So our LFO update is called, it's our retrigger variable is set, our mode is set, the filter frequency top is set, the LFO depth bottom is set. Enough time is elapsed that we're going to update our LFO. And basically this part here is basically detecting if a mode has changed. So if the mode is different than the last time it was called, it's going to reset some things. Because if you don't do this, when you select a new mode, maybe the pitch is going to get stuck where it was and not reset. So I want the pitch to go back to normal if I select filter mode and vice versa. And that's going to happen here. Now this little switch statement is going to take our mode, and depending on which mode is selected, that will determine which case is called. If mode 0, which is the off command, is set, it's just going to return, not do anything. If case number 1, which is the free mode, is selected, it's going to change the frequency of the filter. And if case number 2, which is filter down with a retrigger, if the retrigger is true, it's going to set the LFO to the top of the scale, and then it's going to affect the filter. So it's basically, this is the key. It's using that retrigger variable to reset the LFO. Conversely, if the filter mode is up, it's going to reset the LFO to 0, and then that's going to start the up sweep. Now, if the one down is selected, it's going to basically use this LFO stop variable to determine if it's at the bottom of the sweep. And if it is, this will be true, and it's going to just stop. It's not going to do it anymore until you reset it. And the filter one down section is basically doing the same thing. It's re-triggering, setting the LFO back to the top. But it's using this LFO stop variable to realize when it reaches the bottom, and once it reaches the bottom, it won't reset until a new retrigger comes in. Okay, and like we said, we're using the same MIDI CC for all the modes. So when I jump to case 8, which means my pitch mode is set, this is pitch off, it's basically doing nothing. Pitch free is just using the LFO and changing the pitch of the note based on that. And if I go up to here, notice that I've added this LFO pitch factor along with our bend factor and detune factor to our waveform frequencies. And we've gone over this in the past, so if you're not kind of following this, make sure you watch all the videos up to this point, and hopefully that's going to make more sense. And you know, the pitch down and pitch up are basically the same thing, except I'm using the retrigger variable. And that's basically it. A little complicated, but if you kind of trace your way through the code a bit, it will make sense. It's not that hard. And as always, once you download the code, you want to upload it to your Teensy-Synth board. Go to Tools, make sure your board type is set correctly, Teensy 3.2. Make sure the USB type is set to MIDI, and then just click Upload. And you can see that the code is compiling. It will take a little while the first time you compile it because it's got to compile all the libraries. So just be patient. And your Teensy loader will pop up and upload it to the Teensy. Now you can start your pure data control panel. And remember, we have to go to Media, MIDI settings, and set our sources. And remember, the input device will be whatever your controller is. So right now I'm using the MPK Mini, so that's set. Teensy MIDI should be your output. And then apply, OK. And when you press a key, you should get some sound. Now I have the speed control set to this controller here, the depth control set to this controller here, and the frequency, filter frequency is here, and filter resonance is here. So let's hear how that sounds. So let's go to filter mode, and let's go to down. Now remember, in filter mode, your filter frequency is setting the upper limit of the LFO. And remember, the depth control is setting the lower limit. And the speed control controls the speed. Now let's go to pitch mode, and remember, your depth control is now controlling the depth of the pitch, or how high it's going to go. You can play with the filter and the speed. And let's do a 1 down. Set the speed a little lower. All right, guys, well, that was interesting. I hope you enjoyed this, and I hope you enjoyed this whole series. I'm not sure how much farther I'm going to take the software in this, but if you have any good ideas, please leave a comment below and I'll take a look at it. Now, my goal with this project was to show you how you could start creating your own synth using the Teensy platform. And hopefully you have a good idea about the kind of process and functions you would use to do this. So if you come up with something cool, let me know and we'll share it with the rest of the community. But I hope you're going to take this and start experimenting yourself, because it's really fun to do. As always, I'd like to sincerely thank my patrons on Patreon, and they show up on that big TV, and they have really helped to make this whole project happen. So I can't thank them enough. Thank you so much. So I hope you've enjoyed this series, and we'll do some new projects in the future. So I will see you soon.